we're going to look at how to factor a way that I call payback takeaway. You may know it by a different name. We're going to start with number 2 first. No, I lied. We're going to start with number 3 first. Now, the very first thing that you should always be checking for before you factor this way is the greatest common factor. So I look at 5, 1, and 18, and there's no common factor. So when I factor with the payback takeaway, we're still looking to do the a value times the c value. That's because I'm looking at ax squared plus bx plus c. Okay? So I'm doing the term with the coefficient with a, or with the x squared, and then the constant. So in this case, we're doing 5 times 18. Right? So if we do 5 times 18, that leaves us with 90. So we want to multiply to 90, but I want to add to 1. Now, if you don't know what the numbers are, you just start with 1 and 90. And then I divide by 2 and 45. And then I divide by 3 and 30. And then I keep going all the way down. And in this case, I get to 9 and 10. And then I know that's my last option because if I do 10, I've looped back to this side, and that's all of the possibilities. Okay? So 9 and 10 are the ones that are 1 away apart. I said that word, 1 apart, 1 away from each other. So in order to get to, it's 5 times a negative 18, which gives us negative 90. This is why I always double check my signs at the end, because I have a habit of accidentally dropping negatives. So I do 9 times 10, or to get to positive 1, I need the 10 to be 1 and the 9 to be negative. Okay? Then I do negative 9 times 10, which is negative 90, which before it was a positive 90, so I double checked my signs, and I was like, oh, I dropped 1, so then we're good. Okay? So then what we do is we put our sets of parentheses, okay? And then whatever numbers I just found, they go in the last part of the parentheses, so minus 9 plus 10. Okay? Then we know that in order to get to x squared, we need an x times an x. So I've got an x and an x. Now, we know that in order to multiply to our value of 5, that I need 5 times something. But I'm unsure if the 5 will show up in the first set of parentheses or the second set of parentheses. So what I do is I pay back, this is the payback part, I pay back the 5 to both of those values. But that means I put an extra 5 there because we're not doing 5 times 5. We just want 5 times something to get us to 5. Okay? So instead of, we have an extra 5. So to get rid of the extra 5, I take out and divide the whole thing by a 5. Okay? So then I look at my first set of parentheses here and I see if there's a greatest common factor. There is not, so I leave that as 5x minus 9. In my second set of parentheses, I look to see if there's a greatest common factor. There is. The common factor is 5. So if I take out the 5, we end up with 5x divided by 5 is x, and 10 divided by 5 is 2. Right? So then we divide that by 5, so then those 5s can reduce to 1, because remember we paid back an extra 5, so we're going to take away the extra 5 that we had. Okay? So then that leaves me with 5x minus 9 times x plus 2. Now, you can do this synthetically off to the side and forego showing all of this work. The way that you do it synthetically off to the side is that you've got your negative 90 here, you've got your 1 here, you've got your negative 9, and your 10 here. Okay? So I pay back the 5. Okay? Oh, let's not use that color. We'll do orange. So I pay back the 5 on both of these. Then I look here and I say, is there a common factor here? There's not. So I leave it as is. Then I look here, is there a common factor here? Well, yeah, there's a common factor of 5. So I divide by the common factor. So 5 divided by 5 is 1. 10 divided by 5 is 2. So then I put that in parentheses. So the way that I take this is your first number with the x, this is your number that's by itself. This is your number with the x, this is the number by itself. So 5 and negative 9 turn into 5x minus 9, and 1 and 2 turn into 1x plus 2, and then I don't need to write the 1 with the x. Okay? So let me show you what happens when there's just a 1 in front. So this one we had something other than a 1. We had the 5 in front of the x squared. In this first example, we have just a 1. Okay? So what happens is I want to multiply to 1 times negative 42, which is negative 42, and add to 1. Again, hopefully you're starting to get to your numbers quickly. 6 and 7. I need 7 to be positive to get me to positive 1, 6 to be negative. Then I double check negative 6 times 7 really is negative 42. Okay? So if we do this without doing it synthetically, so we're showing our work over here, okay, then I need to write the x's here, and then we put the 1 here. We put an extra 1, so I have to divide by 1. Well, I'm going to look for a common factor. Now, what happens here is that both of these parentheses, neither one of them have a common factor other than 1, right? So it ends up being a special case because even if you were to factor out the 1, so let's say we factor out the 1, then when I cancel the 1s, it still keeps it exactly the same. So when you have a 1 in the front, you can just shortcut it, and these two numbers give you your sets of parentheses for the answer. Okay? So if we look at number 2, the very first thing you should always be checking for is the greatest common factor. So I look at 5, that's my smallest number, and I know that 60 and 160 both have 5 that go into it because they end in 0. So I'm going to take out the 5. So if I take out the 5, we do 5n squared divided by 5, which is n squared. If I take out the 5 of 60, we do 60 divided by 5, which is 12. So negative 60n divided by 5 is negative 12n. And then if I do 160 divided by 5, that gives us 32. Okay. Now, we want to, again, concentrate on this part that's left over. So we're going to do the 1 times the 32, we're multiplying to 32, and we're adding to negative 12. So then we've got 1 and 32, 2 and 16, oops. 3 doesn't go into it, and then we have 4 and 8, 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it, and then 8, but that's over here, so we've looped back, so these are all my options. Or if you're checking as you go along, you can see that the 4 and 8 will get you to 12. So if I do 4 and 8, I need it to be negative 12, so I need both of those negative, and then negative 4 times negative 8 is a positive 32. Don't forget to keep your common factor out in front. So then I just have negative 4 and negative 8. Since this is a 1, this just goes to n and n, and then this is my final answer. Okay, so let's look at another one where it doesn't have a 1 in front. So if we look at this next one, okay, so I'm looking here. If I look at my smallest number here, our smallest number is 12. All right, so if I think of 12, we've got 1, 2, 3, 4, 6, and 12. Okay, well, if I look at 42, I know 6 goes into that, but 12 doesn't. So I'm going to see if 6 goes into 294. So if I do 294 divided by 6, it goes in evenly, so I'm going to take out a 6. So we get 2x squared minus 7x minus 49. Now, I'm not positive that 6, notice I didn't check 12, so I took out the 6, and then I'm going to look at what's left over and double check to see if there's any other common factors. If there's any other common factors, it means that your number that you got originally was just a common factor, not the greatest common factor. So between 2, 7, and 49, 7 and 49 have a common factor, but not with 2, so then there is no common factor that's left in that set of parentheses. So 6 was my greatest common factor. Okay, so now I'm going to take my front numbers, or my front number. Make sure you're taking not the common factor, so the ax squared part. So I'm going to do 2 times 49. So if we do 2 times 49, that gives us 98, and it's negative. And then I'm going to add to negative 7. 98 is probably a little bit higher, so most of you, I would guess, would like to use a calculator for that. So I think 1 and 98, then I'm just going to start with 2, so 2 and 49, and then 3 doesn't go into it evenly, then 4 doesn't go into it evenly, 5 doesn't go into it evenly, 6 doesn't go into it evenly, and then we have 7 and 14, and notice I'm trying to get to 7, so I'm going to stop here. Okay. So because 7 and 14 get me to 7. So we have our 7 and 14. To get to a negative 7, I need the 14 to be negative, the 7 to be positive. I double check 7 times negative 14 is negative 98, which it is, so I'm good with my signs. Now, you can do it, again, I'll show you without the synthetic way, and then I'll show you the synthetic way. Make sure you bring down your 6. Okay? So we would take these two numbers. So we would take the positive 7 and the negative 14. Again, it doesn't matter the order that you're writing it in. That's because multiplication is commutative. I'm going to take x times x, because our variable is x, and then I'm going to pay back the 2. I'll do a different color for the payback. So we're going to pay back the 2. But I have to take away that extra 2 that I paid back, right? So then I keep the 6. Whoop, moves the screen. Keep the 6. Here, I'm going to look at my first set of parentheses, and I'm going to say, is there a common factor? Well, yeah, 2 and 14 have a common factor of 2. So I'm going to take out the 2. When I take out the 2, that leaves me with 2x divided by 2 is x, and then negative 14 divided by 2 is negative 7. Okay? Then this set of parentheses, I look and I say 2x plus 7 does not have a common factor other than 1, so I leave it as 2x plus 7. And we're still dividing by 2 because that's our takeaway that we paid back an extra part. So then we look to cancel. So notice this 2 will cancel with this 2. They reduce to 1. So then that leaves me with 6, x minus 7 times 2x plus 7. Okay. So that becomes my answer. Now, one thing that I do have to caution you about with the payback takeaway is that you can't catch your greatest common factor at the end if you forget it at the beginning. You can in all the other ways, but you can't in this way. Particularly, you can if you're not doing it synthetically. If you do it synthetically, you'll miss it, and it can be problematic. Sometimes synthetically will catch it if you're doing it the right way. What happens is that you'll have a common factor in both sets of parentheses, so you take that out and then it won't reduce as much. So just make sure you're always doing your common factor first. Okay. Now, if I do it synthetically, so we've got our negative 98, our negative 7, we found that it was 7 and negative 14. Okay. So I'm going to take and I'm going to pay back this 2. Make sure you don't accidentally take the 12 or the 6, right? You don't want either of those numbers, you want the 2. So I'm going to pay back the 2. When I pay back the 2, I'm going to look here and say, do these have a common factor? Well, 2 and 7 do not. So I move to the other side. Do 2 and negative 14? Yeah, they have a common factor of 2. So I like to just cross these out. 2 goes into 2 once, 2 goes into 14 7 times, and I keep it negative. So you also have to remember your greatest common factor when you're doing it synthetically off to the side. So when I do this synthetically, I like to write my 6 automatically so that I don't accidentally forget about it later. This goes with our x value, so 2x, and then the 7 is by itself. The 1 goes with our x value, so it's 1x, which is just x, and then minus 7. So that's the payback takeaway. And that is how you can use that for factoring.